Okay, so here we have an electrolytic cell with zinc and copper again. And you notice I have zinc in solution here, and that's because if zinc and copper have to react, that means that copper would oxidize, which would cause the zinc ions to reduce, but we know that zinc's more reactive, zinc metal's more reactive, so it would just become a zinc ion again. So this won't react the way it is. This is a non-spontaneous reaction, like all reactions are for a electrolytic cell. But if we want to plate this electrode here, my copper electrode, with zinc, then we have to force it to happen. We do that by applying a voltage. Okay, so we want to apply the voltage so that my zinc ions are going to be attracted to this electrode. In other words, we want to plate the copper electrode with the zinc ions. We're going to get zinc building up on the copper electrode. So zinc's a positive ion, so I want to make this my negative ion, or negative electrode rather, which is going to attract the zinc ions to that, and therefore this is going to become my positive electrode. Okay? Now to make that happen, to make this negative, I need to push electrons onto that electrode. So I hook it up to the negative side of the battery. Okay? And then I hook the other side up to the positive side. So electrons are flowing from the negative side of the battery and then flowing to the positive side, because that's the way electrons go, from the negative to the positive. So it's a little bit easier to label what's positive, what's negative for electrolytic cells, because it's how you connect the battery that determines it. Okay, the negative side of the battery is connected to the negative electrode, obviously. Okay, the difference here between this and voltaic cells is that now on right here at this electrode, I have this reaction happening. I have zinc ions picking up 2 electrons and producing just zinc metal. In other words, reduction. Okay, and reduction we know happens at the cathode. So in this example with electrolytic cells, the cathode is negative. Okay, over here on the right, I have my zinc ions losing electrons. Okay, so zinc ions here losing electrons, becoming zinc ions, 2 electrons. And therefore, this is oxidation, and it is the anode, because oxidation takes place at the anode. Okay, and so that is going to take this entire electrode eventually will become an ion, zinc ions, and then will plate itself onto the other electrode. So you can see if you wanted to plate something with silver, I could replace this with silver instead, and silver ions, and they would come over here and plate that with silver. That would be how you'd plate something with silver, or gold, or whatever. Okay, and so that's an electrolytic cell, a little bit different than voltaic cell, but the same basic principles in terms of reduction always happening at the cathode and oxygen happening at the anode. Okay, hope that helps.